Okay, let's dive into one of the most baffling, terrifying, and frankly coolest objects in the entire universe, the black hole. It really is the ultimate cosmic paradox, a place where the rules of reality as we know them just completely fall apart.
And that's really the heart of it, isn't it? Black holes are this giant question mark on the cosmic map, a point where our best theories, from general relativity to quantum mechanics, just stop. They don't work anymore. So how in the world does something so nonsensical even come to exist?
Well, the story of a black hole actually begins with the end of something else, a truly colossal star, one many, many times bigger than our own sun. And believe me, its death is anything but peaceful.
So picture this. A massive star is in a constant tug-of-war. You've got the outward blast of nuclear fusion pushing out and its own insane gravity pulling in. But when it starts to run low on fuel, gravity wins. The core collapses like catastrophically in seconds. This triggers a rebound, creating one of the most violent events in the universe, a supernova. And if the star was massive enough, what's left behind is an object with gravity so powerful, it literally breaks the fabric of space-time. And just like that, a black hole is born.
But here's the amazing thing. There's a creative side to all this destruction. That incredible explosion doesn't just destroy, it forges and blasts heavier elements all across the cosmos. And this is why it matters to you and me. The iron in your blood, the calcium in your bones, pretty much the building blocks for planets and life, all of it was cooked up in the heart of one of these dying stars.
Now, let's just clear up a huge misconception right now. Black holes are not cosmic vacuum cleaners, okay? They're not just roaming around sucking everything up. Their gravity is immense, sure, but it's not magic. In fact, if our sun were to magically be replaced by a black hole of the exact same mass, you know what would happen to Earth's orbit? Absolutely nothing. We'd keep going around it just like we are now. We'd just, freeze to death.
All right, so let's imagine we're taking a little trip. We're getting closer and closer to one of these cosmic monsters. What are we even looking at? Let's break down the anatomy of this point of no return. So that boundary of pure blackness you see, that's called the event horizon. Now, it's not a solid surface you could stand on. Think of it more as the edge of a waterfall in space-time. Once you cross it, the very direction out ceases to exist for you. To get away, you'd have to go faster than the speed of light, which, as far as we know, is the universe's ultimate speed limit. It's impossible. Right at the very center, that's where the real mystery is, the singularity. This is where all the mass of that dead star is crushed into a point with basically zero volume and infinite density. Our physics literally can't describe what's going on here. It's like a dividing by zero error in the source code of the universe.
And the scale of these things can be just mind-blowing. The biggest black hole we've ever found, S50014 plus 81, is 40 billion times the mass of our sun. 40 billion! That's a true titan of the cosmos.
Okay, take a deep breath. We're about to do the unthinkable. We're going to cross the event horizon. And this is where things get truly, truly bizarre. Because when you fall into a black hole, you're not just falling through space, you're falling through time itself.
And here's the crazy paradox. For your friend watching you from a safe distance, your fall seems to take forever. They'd see you slow down, your image would get redder and dimmer until you look like you're just frozen at the edge for all of eternity. But for you, from your perspective, the exact opposite happens. The entire future of the universe would flash before your eyes in what feels like just an instant.
So you're past the boundary. What's the experience like? Well, the physical reality is not great. The gravity is so intense that it's pulling on your feet with millions of times more force than it's pulling on your head. This tidal force has a grimly perfect name: spaghettification. It would stretch your body apart until you're nothing but a hot stream of plasma, literally one atom wide.
So that's the classic theory, a slow, gruesome death by stretching. But there's a newer idea that's even quicker. Some physicists think you might just slam into a firewall of high-energy particles right at the event horizon, and poof, you're vaporized instantly. Honestly, physicists are still arguing about which horrible fate is the right one.
And here is the final, weirdest twist of your journey. Counterintuitively, the bigger the black hole, the safer you are, at first. See, with a smaller black hole, those deadly spaghettification forces would tear you apart before you even got to the event horizon. But in a supermassive one, the edge is so far from the center that you could float right across the boundary without even noticing. You'd get to live for a little while before, the singularity gets you.
So, we've seen a black hole's violent birth and the pretty awful fate of anything that falls in. But what about the black hole itself? Does it live forever? Turns out, no. Not even black holes can escape their own end, and their death is a story that plays out over almost unimaginable stretches of time.
This is all thanks to a process called Hawking radiation. Now, the physics is super complicated, but the simple version is this. Right at the chaotic edge of the event horizon, tiny particles are allowed to pop into existence, and sometimes one escapes. Each little particle that gets away carries a teensy tiny bit of the black hole's mass with it. It's like an impossibly slow leak, but over cosmic time, it means the black hole is slowly but surely evaporating.
And when I say impossibly slow, I mean it. The process gets faster as the black hole shrinks, but for the biggest ones, this could take a Google year. That's a 1 with 100 zeros after it. The universe will be cold and dark and empty long before the last black holes even start to die.
But wow, what an ending. After all those eons of slowly fading away, the final second of a black hole's life is a furious burst of energy. It radiates away all its remaining mass in one last, spectacular explosion that has the power of billions of nuclear bombs. It's the final flash of light in a very dark universe.
And that just leaves us with one last, kind of haunting thought. Black holes swallow everything, including information. But that information might not be totally destroyed forever. It might be scrambled and encoded in that Hawking radiation. So when that very last black hole evaporates, way off in the distant dark future, what secrets of our universe, what stories of fallen stars and forgotten galaxies will be released in its final breath? And will there be anyone left to hear them?